So we've looked at some exercises covering the versatility of Microsoft Excel using it as a calculator and calculating probabilities and some statistics. But now I want to show you one of the chief reasons people use Excel, and that's because of its financial applications. And so we're going to look at some examples that use some new functions that deal with financial matters, and hopefully you find this useful and interesting. All right, so first thing is I've already got my 4 questions set up here in A2 through 8, D2 through 8, and then A and D 11 through 17. And just to let you know, these variables, PV means present value. That means the principal, what you're starting with. R is your interest rate. N will be the number of compounds per period. So like quarterly would be 4, for example. T is time in years. PMT means payment, what our payment is, and FV means future value, or what we hope to obtain. All right, and depending on the phrasing of the question, we might be looking for one of these or the other, and I'm going to show you how to calculate those. Okay, so the first example is Angela deposits $3,000 into an account that has a 4.5 interest rate compounded monthly. We want to know what the future value will be after 10 years. Okay, so in other words, we're putting in $3,000 into an account, and we're just going to let it sit there. We're not putting any payments in or anything. How much is it going to be worth in 10 years? So this is just asking about interest accrued. Okay, so we said she's putting in $3,000, so that's going to be my present value. We said the rate was 4.5%, so that's 0.045, and it compounds monthly, so the N would be 12 there. And T is, we have 10 years. And the payment, well, we're not making any monthly payments, right, or payments per period. We just put in the 3,000 initially, so we have a 0 payment. All right, and what we're trying to calculate is the future value. So we're going to use the future value function, which you can say equals FV for future value. And notice the things you need. You need a rate, a N per, a PMT, a present value, and we won't really worry about the type. That's for a more advanced calculation than what we need to consider here. Okay, so another thing is the rate here. What they actually mean is our APR divided by the period. So here we're going to say B3 divided by B4. And this is going to be a common theme you'll see. The N per is actually the total number of compounds. So we're going to have 12 compounds a year, which would be B4, times 10 years, B5. So we have N times T for the N per. The payment is B6, which we know is 0. And the present value, I'm actually going to say negative B2. And the reason I'm saying negative B2 is because it's like that's coming out of my account, okay? So let's leave it positive and see what happens. So I hit enter. I get this value in red. The red means negative, okay? So I have negative $4,700.98. And that's just the way Excel thinks. So if we make the initial investment negative, we get the positive value we want. $4,700.98 is what Angela has after 10 years, which is not bad considering she just didn't even touch it, right? Let's look to our next example. Kevin is going to invest $100 a month. He's making just from his paycheck, putting in $100 a month into an account that has a 3.5% interest rate compounded monthly. How much will Kevin have doing this after 15 years? Okay, so he is not starting out he's not putting any present value in at the beginning. So Kevin doesn't start off with an initial investment, so his present value is 0. We said the rate was 3.5%, so it's going to be 0.035. It's compounded monthly, and we're going to have it sit there for 15 years. And he is going to put a payment in of, we're going to say $100, negative $100, just to help Excel think about this correctly. And this is still a future value question. Now, the reason it's different, even though he's putting in monthly and Angela did not put in monthly, she just put in one initial investment. Her present value was $3,000, Kevin's is 0. Her payment was 0, Kevin's is 100. All right, so here, all right, we're going to use the future value formula again, and we have a rate. We had to say E3 divided by E4, right? That's the rate divided by the compounds. Then we have the total number of compounds, which is going to be E4 times E5, right? That's 12 compounds a year for 15 years. We have a payment of E6, and we have a present value of 0, or we could say E2. All right. And there is how much Kevin will have after 15 years, $23,628.60. All right, great. I hope that makes sense. And again, these are both basically asking the same question. It's just one, we're not putting in a monthly payment, and the other one we are. Excel handles those the same with the same formula. Okay, so Meredith would like to have $180,000 after 20 years, and she's going to invest into an account that has a 4% interest rate that compounds quarterly. What does her initial investment need to be? What's the present value required to end up with $180,000? Okay, so she wanted $180,000 and the rate was 4%, so 0.04. And it compounds quarterly, so that means it compounds 4 times a year, and she's going to have it there for 20 years and with no payments. She's not putting any payments in. How much does she need to invest initially to end up with $180,000 that she needs? Okay, so this is a present value question. In other words, the present value is solving for what kind of investment we need to have initially. And so I say PV. And notice that the things required are basically the same that they needed for future value. We need the rate, which is going to stay the same. So that's going to be B12 divided by B13, right? That's going to be the interest rate divided by the number of compounds. Then we need to know the number of compounds. So we have 4 compounds a year, which is B13, 4 20 years, which is B14. Her payment is 0, but I'll put in the cell B15. And her future value is B11. Now the way I have it, it will come out negative. Okay, so let's go ahead and make that an initial, or the future value negative $180,000. I know it sounds kind of backwards, just the way Excel thinks. And so that's what she needs to invest. If she can invest $81,201.23, then 20 years down the road, she will have that $180,000 she needs. Okay, so let's look at our fourth question. So now Meredith decides that she wants to make a payment instead of an initial investment, but she still wants $180,000. If she's going to do that, what should her payment per period be? All right, so we're going to say $180,000 again with an interest rate of 0.04, compounding quarterly for 20 years. Present value, this time she's not putting in an initial deposit, right? So she has a present value of 0. And the payment function is P and T. And look what you need to put in. A rate, the N per, those are the two things been a constant in everything, and then a present value and a future value. Okay, so we can do this. The rate is going to be E12 divided by E13. The N per, the number of compounds, that's E13 times the number of years, E14. The present value is 0, right? She's not going to invest anything initially, but that's E15. And her future value is going to be negative E11. She wants to end up being owed $180,000. So to do that, she needs to invest $1,479.39 per period, so per quarter, okay? So she puts that in per quarter into this account, then in 20 years, she'll end up with $180,000. All right, now Excel has way more financial functions than this. Have things way more complicated than what we did, but this gets us started. This helps us figure out, we could figure out how much we need to pay a month to get off a credit card debt. We could figure out how much we need to invest initially to save up for college for our kids or something like that. If you have any questions on this, I'd be glad to help. Please let me know, and thank you for watching.